live. Hey, Matteo.
Hi Luca, hello, hi everybody. I'm very happy to be here streaming today. This is actually a new experiment, so I'm very actually happy to that we started doing this. So hey,
Yeah, and probably this one, like you just said, is the kickstart of this new initiative that we wanted to bring to everyone, starting this series of like webinar. Because the truth is that we have been, you and I, on plenty of webinars that we attend with a good intent to get some, you know, on the ground knowledge that we could reuse. And yeah, it was always hard to get something out of the those sessions. So what we wanted to do was to bring all our experience, uh, at everyone's disposal to, for everyone to learn, to hear something new, to kind of like jump on this journey with us. And don't worry, you don't have to take notes. We are going to send everything out. Everything is in the open as per Platformatic nature. And so the recording, the transcript, and everything will be completely available to everyone. But maybe we should kind of like jump into the reason of this webinar, starting maybe telling a little bit about Platformatic, no, Theo?
sure, let's do that. Let's jump into Platformatic, Luca.
Well, we cannot say that is the sponsor because it's the sponsor, but it's not sponsoring, it's us.
It's us.
So
So we decided to do this, and let's see if we can be online with it. Come on.
yeah, and 30 seconds for our sponsor, Platformatic. Platformatic, now what we do, we live and breathe Node.js, right? That's who we are. And what we are doing, we are building the next generation platform, cater for the enterprise to run Node.js application. Very simple, very streamlined. And clearly, stay all tuned because we are launching new feature very often. But I mean, we gave the time to our sponsor. Now I think it's time to move to the reason of this webinar, right? We started saying no mumbo jumbo, so let's keep it and go straight to the point. Um, so the reason why we're here is that, well, I personally jump right off the magical deadline of tax season. So I know what having everyone jumping in one channel to deliver every single financial paper means, because I was in the queue. But maybe, Theo, because it's the first webinar, let's maybe do a quick intro on who we are for the people that maybe don't know anything about us. It's kind of hard, but maybe if you can spend like 10 words on yourself and then 10 words on myself, and then we jump into this
Sure,
straight.
let me start. So I started doing Node.js a long time ago when Node.js was at version 0.2. I have accumulated an infinite amount of npm, infinite no, but maybe around 600 npm modules with more or less something like 30 billions downloads per year at this point. Um, because I didn't have enough, I had a lot, way too much free time. I ended up also being one of the maintainers of Node.js. And in all my journey, a long time ago in San Francisco, I met Luca and we worked together for a bit. We didn't work together. Then we decided to start a company, and essentially, Platformatic was born. So I don't know if that looks like what it is. Oh, in the meanwhile, I created a web framework called an API framework called Pino, HTTP, that a lot of people are using. Probably most of you that are listening, if you're not using it, you probably should. And then I also created a logger called Pino, which is probably the best logger for Node.js for production use cases. I don't know. I probably have said a lot, so maybe Luca.
Yes, the framework was Fastify. You said Pino, but I think
Yeah,
you
yeah. Oh, yeah.
kind of
Sorry.
like
Yeah,
uh,
yeah. Fastify.
myself just like jump into Node back in 2011 and explore it and exploit it in many enterprises, work with Matteo. I am an addicted entrepreneur. So here I am, few companies later, building another one. trying to change the world for good in the enterprise Node.js ecosystem. And extremely happy that on this journey, I'm running this journey together with Matteo. Definitely, probably the most one of the most relevant expert in the field. So very happy to be here. But let's go back to our webinar so that the people can enjoy a little bit our chat, because Matteo and I love to chat. So that's one given point. Um, so maybe Matteo, let's start with something that comes from our experience and a little bit from working together, working separate in different environment. Um, what are the main alarms? What rings the bell for Node.js applications performance?
Oh, it's actually, you know, um, more or less, I would have to say two things. Okay, usually it's three things, but this time it's actually two. Okay, so the biggest problem, especially in this period of the year, is applications certainly becoming unresponsive, as well as your Kubernetes cluster randomly killing some of your pods because they are hitting some limits that are set in the cluster. Both things are extremely annoying, and in my experience, most companies are not doing it properly. So, and they are hitting this at scale every single time.
Yeah, and I think we kind of like shared a lot of interesting stories in the time that we worked together. But definitely one thing that we both noticed in every single conversation was that Node is a different beast, right, than many other technologies, but especially when you put it in Kubernetes. Uh, Kubernetes was born to abstract physical infrastructure, but then Node. And last week we actually said the same thing to one of our customer, right?
Yep.
Node works with logical resources. So there are two worlds that they clash when Kubernetes needs to scale, and Node says, "No, I'm still good." Um, Maybe we should kind of like give a little bit of a hint about that, because what I was surprised about last week is that I thought it was common knowledge. It was something like everyone knew that Node was working in this way, but apparently even the most expert, the people that are running Node at large scale in production for real-time systems that they keep our economy safe and flourish, they didn't know. So maybe we can share this with everyone. Well, last week we spent more than an hour. Maybe we can keep it condensed. But what's interesting, maybe Matteo, is like,
Should I keep something that explanation condensed, Luca? How you dare, uh, keeping my mouth shut and not explaining all this amazing knowledge to everybody for an hour? I need to take the whiteboard. I can put a long whiteboard here and start drawing things for an hour. Would not be good.
you
No.
can use a Sharpie on your background. Then we can slide it in and out. No, but I mean, don't you find it interesting that the memory model and the CPU model that Node decided to adopt? Like, to me, it's kind of like super interesting. Like the garbage, how the garbage collector, for example, works, and how the memory allocator works.
So it's so first of all, I'm preparing some material on the garbage collector. So if you want, these will be out in a few months. So hopefully, finger crossed, you will love it. Okay, let me go a little bit and give you a gist of the garbage collector and the first problem. Okay, so the first problem of running Node.js um, in production is you can configure essentially your Kubernetes system so that if your application hits a certain memory threshold, that application is shut down. Okay, because it means okay, I give it, I don't know, 2 GB of RAM that it can maximum use. If it reaches 1.8 gig, I'm killing it, or I want to shut it down because it's probably leaking memory. Now that's not how Node.js work. Okay, you have seen it with Chrome every single time you open a tab, okay, it allocates a bunch of memory and almost never release the thing. Okay, why it does that? Okay, because it prefers interactivity. Okay, so it does collect memory when it does not have any more memory to allocate. Okay, or when there is very little activity in the process and it can, do some cleanup. Okay, it's lazy as a developer. Okay, so that's the point. That's how it operates. Okay, there's a lot of documentation on the garbage collector. We'll putting out some content sooner rather than later on the topic, but the generic hint here is it's lazy. So the fact that you use 1.8 gigabit out of 2 gigabit doesn't mean it has a memory leak. Okay, it just means that at that point in time it needed that memory. Okay, but what it happens is V8 allocate memory using the concept of a heap. So when the heap is full, it says there is more memory I can use. It grab another chunk of memory and expand its heap. Okay. Then in the heap, it put the objects. Okay. So, but it can keep. But then once he has enlarged the heap, when it has increased the size of that heap, it retains that large heap. So it will never go down almost. So it doesn't make much sense to kill Node if it uses a lot of memory, if it's controlled. Okay, so that's the overall point. Not that there is a concept of new space, old space, but probably Luca is going to, uh, cut me sooner than that, so I'm not going to it.
No, we
But
still have time. If you want to deep dive, we still have time. I think we still have an half an hour to chit chat.
okay, well, I want to touch other things. Come on. Okay, so this is the first problem. Okay, it's a garbage collector. The second problem is when the system becomes unresponsive, okay, due to the event loop. Okay, now that is the second biggest problem. Um, when you're building an application with Node.js, you need to be very careful about what is called event loop utilization. Doesn't really matter on how much CPU is using, but it really matters a lot what is the current event loop utilization of your system. What is the event loop utilization? Well, it's the time, it's a percentage of the time your event loop is busy doing stuff, serving your customers, your clients. Now, what it means is, if your event loop utilization is 80%, it means that there is 20% that your event loop is absolutely idle and it can accept new connections. Now, when it reaches 100%, it means that your things are getting accumulated. The tasks, the requests that are coming are getting accumulated, and to the point that it reaches a point of no return. Okay, in which the new requests that are coming in will never get a response in any timely fashion. That's the worst possible situation for your Node app. All things, if you're not scaling Node.js fast enough, if you don't have a good autoscaler system set up that's looking into this variable, you are going to have a lot of problems in production. And most companies do not have a good autoscaler set up, right, Luca?
Well, the reason is because everyone keeps the default, right? That is in Kubernetes. I think, I mean, when we look at the problem, right, and maybe we can then tell a story to everyone. But the first question that, and I remember we were in Amsterdam when we discussed about this problem, was March of last year, and we said, well, I think the biggest issue is that there is such a huge buffer of resources that are unused or badly used inside of a cluster, that I think we can probably say one order of magnitude in resources and capacity inside of a cluster just by writing a custom algorithm for the scaler. And that was the time that we kind of like said, well, why don't we just like take the metrics that really matter and then instrument the autoscaler? Because I don't think it's well known that the scaler can be instrumented. You can basically tell this is the data when you arrive to this threshold, scale, I give you the metrics, I give you the data flow. And so that's what we did. And I think, to be honest, unsurprisingly, was the right thing to do, because if you look at how even OpenShift or Fargate or in GCP, is very generic, right? There is the lack of context that is what I personally feel is lacking completely in modern infrastructure. We took this huge leap in a leap of faith, if I can be provocative, in the cloud, and then we realized that the cloud was just a generic tool, because that's the best way, right, to scale it for the cloud provider. And the same for Kubernetes, and the same for many other tools, because they need to keep it generic. But I think, based on your knowledge and the depth that we could go with the Node runtime, it was a natural choice for us to kind of like specialize it, find a specialization for, I call it the modern or the future of the cloud infrastructure. So yeah, I think the problem is that we have all these primitives that are extremely powerful, but extremely too generic. And that's where I think a Node becomes like a headache, because how many times we said Node is super simple. You can just create a Node server in no time. You don't need anything. You just need to, download Node or install Node, and then just call listen on a HTTP server instance, and the job is done. But behind that and beyond that, there is so much to make it really,
Well, it's
powerful.
it's very simple here. Okay, so if you're building something with, I don't know, um, most other languages, okay, most other languages can only accept only very few request in parallel. Okay, while Node.js being event loop based, you can accept so many. Okay, this is something that a lot of people complain that this language or the other language are slow, whatever. And the major problem for that, it's because essentially they need, in order to scale, they need to allocate a lot more threads to be able uh, to spin up all those requests. One request, one thread. This is the old model, which means that you can't get really more than 1,000 running concurrently on any reasonable machine, because after that the system will eat you alive. Okay. Now the problem, um, uh, the solution for this, and for Node being event loop, when Node came out and popularized event loop system, this was, wow, I can run so many requests per second here. Now, what happened after, okay, is, okay, why this makes sense? Because a lot of applications are really CRUD based. Okay, so this means that I need to read a database, read data from a database, deserialize the content, process it a little bit, then send it back. Okay, you know, or maybe doing a few API calls, orchestrate the response for my backend from two different services, and send that request back. For this kind of stuff, Node.js is phenomenal. Okay, now however, it can be used for a lot more. And something that has been becoming popularized is also doing some, I don't know, some heavy CPU tasks. Okay, and those heavy CPU tasks is where you need to be more careful. Okay, so, and try to avoid doing a lot of CPU intensive operations that would essentially make your system reduce a lot the capability of your system. But, or if you want to do that kind of model, well, maybe you should think of, I don't know, start also doing some multi-threading, either with our tool, which is called VAT, which can allow you to spin up multiple instances of the same app, listening on the same socket on multiple threads. Okay, or essentially doing it with Pishina, which is does something slightly, you can do it something slightly different. It has a little, it has a few different constraints in it. So depending on your case, it might be one might be better than the other. And yeah, but you need to think a little bit about those things. And it's especially when you have a lot of load. Okay, so
But I mean, I think two things are pretty interesting. Like the first one is that, and then I think we should tell a story because
yeah, I think
it
so. We
connects.
should.
It connects to this thing, and um, when you basically say that Node is great with stateless application, right? Because that's basically how it was born. Um, I think, to be honest, you are completely right, but at the same time, is because something was missing. Like, I'm not trying to sell what we build because most of the things that we are building are open source, by the way. So there's nothing to sell, it's just to download. But I think the trigger for us to look beyond Node itself on what it was exactly that we said, why in other languages I can do this thing and I cannot do it in Node in an easy way, because you can do it in Node. I mean, I think with your expertise and many others people's expertise, everything is possible. It's just a matter of like how deep you know the tricks, how deep you know how to play with streams versus other things, right? But for us was all about accessibility. And when we thought about what, and we said, why do I need to stress about thread management? Like when for example, it's kind of funny. I can tell that because it's nothing illegal, but um, we were
You,
looking, I think you were looking to buy your previous Mac, and you
yep.
couldn't find where it was available. And I wrote this terrible piece of code that was searching through all the availability in the Apple stores and online for all different type of configurations, because I figured it out that each configuration has a unique SKU code. So well, and I think it was in Lambda, something like that. And then I used some sort of like you know worker threads to kind of like parallelize and do multiple research in one. But it was such a huge pain to synchronize even the async code, like, because generally speaking, it requires a different level of understanding on how the async way it works, on how basically the different function implemented in the npm package work, and blah 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 blah. But when we thought about what, we actually wanted to abstract the problems of multi-threading, and say, well, I can spawn different in separate threads, let them do all the same stuff, and problem is solved. But I think is going back to your point, and just to keep it like conversational, I think it's kind of funny when in 2017 we got that phone call to jump on the first flight for New York and go to that big media company that we cannot name, because they say, we are the CTO definitely said, you guys need to come or else we cannot launch our new homepage. And it was all about server-side rendering. Was probably that one was the beginning for us to understand that there was a gap
Yeah,
between the two worlds, right?
yeah. So it is the problem with server side rendering, and we have written a long blog piece in the summer, which got a lot of attention. So you might check it out, and was a little bit controversial. We made some mistakes. Anyway, what we showed is that if you do a very complex page and you do a server side rendering it, as the current guidelines for providing the best user experience would tell you to do, okay, because that's what it is, okay. You What will happen is that your server will clog very quickly because you have a server-side render application with React or other technologies. I don't know. You can probably render between 50 to 100 per second at best. Okay, maybe even in some cases, if the page is very complex, 10 per second. Okay, it means it's actually very CPU expensive. That
Well,
okay.
they were spending millions of dollars in cloud every month to render a web page, homepage, right? So
So, and in a lot of cases, those companies, okay, and this happened later in some other engagement where the company was doing some consulting with had couldn't do any caching. Okay, like a part of the solution to that problem is apply caching. Okay, so you cache the result. Okay, so you don't do server side rendering all the time, but you are able to cache some of that response, some of that page. So it's only done every once in a while, and therefore you can respond very snappy, ideally from the CDN or something like that. It's great. Okay, but what if you can't? Okay, and if you can't, and you have to, you know, render the page every time because of feature flag, of other things, A/B testing, you name what. Okay, you are in
Also
trouble.
for data constraints, right? Like for
Yep.
example, if you are a bank or if you are anything, you cannot really cache personal information or healthcare information.
Then you have all this problem and you need to handle the server side rendering. Then you need to be very, very careful on how you manage your your solution. Okay. And one of the option has been, of course, it's been popularized by a few companies, is okay, this is a CPU intensive task. We can, put it on Lambda and scale that essentially forever. Um, well,
Does
you're
it
probably
really?
yeah, yeah. The fundamental problem with Lambda and every single company that I've worked with that have tried to run Lambda at some good scale ended up with is when you're doing AWS with AWS Lambda, you have one limit, which is how many invocation you can do, how many Lambda instances you can have, okay, running for your account, your wall account. Okay, this is the key part. Okay, so if you have multiple applications running on the same account, then the limit applies to that. Okay, and then you can have one application that starves the other one. Okay, because of all these Lambda invocations, and this is really, really, really problematic because in case of a bug or something is not working correctly, essentially a bad Lambda can bring down your that wall account, which it's not a fun experience if you ended up being on call. Uh, I don't
But
really like being on call, but that's what I done a few times. So
but didn't they tell us that is Lambda is serverless, right? So there should be no boundary.
no, there is no serverless. Yeah, there are no
So there's no
servers.
server.
Yep, there's no servers, right? They run in the Ethereum, in the
But they still send me the bill at the end of the month. That's the thing. That's the thing I don't get, right? So that maybe is a topic for another, episode. But don't you find that it's kind of like funny how marketing or how we can shape these terms and create a movement with people, right? Say this thing is serverless; it doesn't exist. It's you don't have to care about the server. But then the reality of fact is that you have even more constraint than having your own server because, like you just said, these limitations are hidden, right? And when you are dealing, and we go back to our initial point, right? It's all about setting the primitives and the constraints for the runtime. So the things that kind of like drive me a little bit, I mean, it's the great opportunity for us because we're building the primitive for Node in enterprise. So definitely, I mean, we hit the nail on the head perfectly. But it's kind of crazy, right? The dichotomy between the infinity that is described by all these terms and the reality of facts of what this runtime needs. So the physical world versus the
so
logical world of resources.
yeah, it's fun because so especially when you have a burst of requests. Okay, especially let's say uh, at at the end of a deadline. Okay, you have a deadline set at that time. Okay, and you've built the UI system for that deadline. Like it can be uh, the tax season, or it can be um, whatever. To be honest, okay,
It can
and
be Black Friday, it can be anything. I mean,
it
tax
can be
season
Black
to me,
Friday, or well, you know what? Well, you know one of the funniest case that I worked in my career is a system for voting, online voting platforms for marketing campaigns. Okay, For example, I don't. A lot of some of you might be Italian, some of you are, and some of you are European. Okay, and if you are, you might know that right now there is a Sanremo running in Italy. Okay, did you know that there was Sanremo, Luca? Were you
I
aware?
don't know. It's one of the things that I kind of like enjoy forgetting
Every year. Oh, you can't
every
forget.
year.
I still live here, so I can't forget. Okay. Anyhow, if you have in a short amount of time a burst of request for something, okay, then you are in trouble. You can get in trouble for that kind of approach for rendering and doing all the things. And if your application is not built to scale up, okay, you it doesn't work. Okay, it can crash. It can provide bad service for your people, for your users. So, and this is kind of the problem of, and a lot of companies do fixed scaling. This is fantastic. Okay, and this is
Oh
I don't
yeah,
know.
that's
They do
actually kind of funny when they do.
like they do fixed scaling. Okay, so how does fixed scaling work? Okay, so they think, what is my max peak traffic that I can get, or I'm thinking that I can get? Okay, this is I allocate for this. I don't know 128 servers to do this. Okay, and that's how they run it. And then they usually complain that the cost of cloud is so massive. Okay, and then they try to move something to Lambda, and it doesn't work either because it blah blah blah. So they don't know they ended up being in the middle of all of these things. So the key challenge here is we want something that works very well under a lot of traffic, okay, and costs little to scale, okay, but also it doesn't have massive fixed costs running all the time. And ouch.
Yeah, because that was not right. The lowest and lightest footprint in terms of like resources. No, it was light, right? Do you remember, Theo, like in 2014 and 15? Oh, it can run on a Raspberry Pi, and
It's still,
Java
it's
cannot
still,
run on a Raspberry Pi,
it
right?
still ran on a Raspberry Pi, Luca. It still runs on the freaking
But
Raspberry Pi.
but
Come
then
on.
look at the kind of like opposite thing, right? That we just said you need a huge amount of resources to run it at scale.
Well,
When
as
when,
everything,
when
you have traffic, you have users, right? So you need resources to because you have users hopefully
yeah,
paying.
but the thing is that if you think are expensive resources, like at the time, I don't know. I mean, probably you played the same experiment I played. I took a Raspberry Pi, I put an application, and I simulate load on this application. Said it runs for 50 euro. It runs better than 10 grand server, something like that.
Oh yeah, but then we decided that to put a lot more behavior there. So and now it's low down.
But that's the thing, because they told us that the primitive was Docker, and Docker would equalize, right? The runtime would equalize everything. But I didn't see really that equalization. I think, I mean, if we tell, like, we have 10 minutes, so let's tell a couple of stories to people, war stories, the things that we lived. We told that the huge media company, uh, the same applied, you remember, in August, just like after a few months, for the big e-commerce company that was running every day. They were adding 20 or 30 EC2 instances to kind of like keep the website up and running. That was actually kind of like genius. I was like, yeah, you remember, I was going to the airport and I said, shall we make a bet on what's the problem without even
Ah
see
yeah,
the code? That
2 hours.
was kind of like, that was next level, I think. It
Yeah,
was
yeah. Look, we did. Yeah, those were fantastic stories. So
because they were all copy paste, right? They were like a cookie cutter thing, like the server side rendering. We almost came to the point to say it's always this problem because everyone
no, it's
falls
still
in that
always
black.
that problem. It's still like if you look at our data, it shows that the cost of rendering some HTML using the so-called modern web is you know so high. And there is, to be honest, not much energy being put on some of those frameworks to improve that situation. So
Well, but it's not only the frame, right? Because it's, and I don't name any company, right? So we are not here to kind of like shit talk or like do anything, negative, talk negative. But the reality is that it was the great opportunity for a lot of edge company to kind of like promote a new layer of infrastructure, right? And say the patch we can put is to have an infrastructure that is at the edge, and we can handle your front end application. We can run at scale at an insane cost, right? And so you see that companies like many of the enterprise that we helped before, being Fortune 500 companies, and many of the companies that are nowadays our customers, they already made the investment on their infrastructure, and they feel almost forced to move to a new OpEx, to buy a new appliance, to just like render a website, when, to be honest, we should bring the tools back to their infrastructure, right? Because they're already paying for that. And you said it in the beginning, Node is super good at doing stateless stuff, like a simple CRUD applications. And that's what is the back end of the front end, right? Most of the time with GraphQL, with traditional REST. I mean, we saw last week, and we saw many other times, the architecture of the modern web is the one of 1990 probably, which is I have a front end, is the JSP. Let's be very honest, it's JSP in a
it's
modern
not
extension.
JSP. It's not JSP, Luca. Okay, so
ASP.NET.
it's so the precursor of the modern web was done by, I think it was called Java Server Faces. The first instance was Java Server Faces, and which essentially created a full DOM element, a DOM-like system on the server, rendered all the DOM components, then took that, serialized that, and that was essentially recreated on the front end, hydrated to add behavior. Now, if it looks like that is what React does, yes, that's exactly what the React does, and it's exactly the same pattern.
Do you
And
remember, Theo, at the beginning of Node? So let me try to remember the exact time, but it was back in 2012, 13, kind of like time frame, when Airbnb kind of came out with that library called Render, to do basically isomorphic
oh,
application with Backbone JS and so on. I think that was like the beginning of the end,
no,
because
I
everyone started to like build this kind
from
of like monstrosities.
from my point of view, it's great because they make sure they allow developers to be way more productive, okay, and make them way more empowered to ship good apps. Okay, so they have a absolutely good side of things. Okay, and they enable teams along all over the world to be super fast and super good. However, they pose a new challenge. They raise the challenge on the infrastructure on how to handle those systems, and that's what's usually not taken into account. And then you go into production and you realize, oh, and I put beep, and they and things do not work as expected. And now basically it's not problem. And how come it's not problem? Okay, sorry, I'm just putting it loud, but um, it's not problem. Of course, it's that they didn't realize that they need to do this, that, and all those other things. Okay, um, I don't think we have enough time, but I just want to explain a little bit, and maybe we can schedule a session on this topic later. But
No, try. We still
there
have
is
like 5 minutes. In
magic.
5 minutes.
It's called, okay, the what I call the triangle, okay, and of CPU usage, memory consumption, and latency. Okay, and if you when you have one raising up, all the other raise at the same time. Okay, so the more latency you have in the system, maybe doing a database call, the more memory you use and the more CPU you consume to clean up that memory. So this end result means that a little bit of slowness in the system as kind of can have a domino effect. And you need to auto scale, and you need to scale your system, and you need to do a lot of those. You need to know how to monitor this. Like, one of the questions that I get the most is, how do I set up my Prometheus monitoring dashboard to know what's happening in Node.js? This is one of the
Everyone
most.
wants a dashboard.
Yeah, but
It's
they
a
don't know.
new.
But they don't know. Like, literally. Or the second question, okay, if they have the dashboard and they have the problem, okay, the question now is, oh, I have all this nice, beautiful data. I don't know what to do with it.
Well, but you and I mean, have probably 10 hours of stories where you see this war room of people, top higher up, principal architect, principal engineer, blah, staring at, Dynatrace or, Datadog or anything, right? And looking and say, and now? And to me, it's fascinating, right? Because there is such a great, I think we were given all the data sets and the data streams that we needed to kind of like make sense out of it. But like you just said, we kind of like didn't really action them. And when I say we, I see it as a community, right?
Yeah.
Is because one thing that I always complain, and is that I say, well, but Node is a great runtime, it's cool, right? But at the same time, what's missing in Node is the whole ecosystem that allows me to use it at its top power. Like I come from .NET, right? From having even the IDE, right? That I'm highly against an IDE. You and I share the passion for Vim, but on the other side, there were tools that they enable people to just like put a breakpoint and debug and see, and you have performance counter. You have all these kind of things also in Java. You have the tools. You have WebLogic. You have IIS in Java and .NET. You have JBoss. You have let's not name all the
Not
application server in the
those are,
world.
those are not good memories in most of the
They
cases.
are
Those
not,
are,
but I think for the enterprise, I think for these large scale organizations, there were needed tools and needed. Well, that's the reason why you and I kind of like decided to start this crazy adventure with Platformatic, to rebuild everything that is needed for running Node at scale in enterprise. And
yes.
like what that you mentioned is, I think, for the first time in a very long time, probably for the first time in like 11, not 14 years. Yeah, 14 years. I find that Node is really kind of like, I have something where I can just like think only about building my own code. I don't have to think about logging, tracing. Did I forget anything? Right? No,
Well,
this thing is going to take care of
you
that.
kind of, well, yes and no. Okay, if you yeah, you can sit in a corner, bad corner of the world, where you still need to figure it out. Okay, but if you use what we have built, if you use Pino, if you use Fastify, things are great. Okay, it's a great spot. If you can still be doing old stuff, and then you are in trouble. Okay, but yeah,
Yeah, but it's kind of like the nature, right, of like
yep.
technology. And like like if we want to say some other stories, we when we were together also in New York, and we helped a large organization to figure it out how to handle their distributed development, right? Because they were using Node, but they were like incapable of like coordinating work across the ocean between the two different teams. And that was, I think, the beginning. You remember that for us was like the beginning of the conversation about like growing Fastify, but at the same time was the beginning of the other tool, Doctor, that was kind of like born at the time. Because uh, at the end of the day, the truth is that the ecosystem empowers developer, like you said, but actually lacks the tools and lacks the capabilities for the operators to support developers. And so now you have this kind of like factotum, the so-called full stack engineer or so on, that they try to do everything, and then it becomes
Failing.
very hard to do too many things all together to support the application in production. I'm looking at the time. We said 45 minutes. Do we want to be precise and say 45 minutes and invite everyone to the next, or you have anything else that you want to chat
No,
about?
we can look. We have done our thing. We can, I don't know, answer the questions. Okay, and then if there are, okay, I
Yeah, so
think
keep
there will
an eye
be.
on the questions, and then we can, if there's any
Let's
question,
take a
we
look.
can answer online or offline.
There
And
was a question before about the Lambda invocation limit. Okay. In order to raise your Lambda invocation limit, you need to contact the uh,
AWS.
AWS support to get it done. This takes a few days. Okay. Now, if you forget to do this, this is a problem. Okay. And you have a spike. This can be a huge, massive problem. By the way, of course, this is a scar on my back for this. Okay. Another problem is if you have a situation, uh, um, uh, you have with if you have a situation with Lambda, for example, where you have a function that keeps failing. Okay. It can quickly but it fails after a long time. Let's say you have put a timeout for this over a few minutes. Okay. And you have not put a maximum amount of limit on how many invocation of that can happen. It can easily starve all your pool very quickly, waiting for to complete. And literally, this is like, I don't know. Lambda is a great system for spot work. Okay. I Generically, I would not use it for production HTTP load if I could avoid it. Okay. So yeah.
do you see any other question?
Um,
And if anybody's online, don't be shy. We don't bite. Well, if there's no other question, I would say that we really did it almost on time, which is already a huge accomplishment for the two of us. I think it was a good first chat. I mean, we need to.
oh, there is a question, Luca. Just question just arrived. When we started. So there is a okay, so this is good. There is a concept where people assign micro CPUs to node apps, which result in scaling on a single machine. Can you speak about that, Luca? Oh, you will love this, Luca. This is with love.
I mean, I it's a very hard to not be very judgmental on that choice, but let's start saying that when you are in Kubernetes was well designed to support massive pod size because the utilization and how the resources are kind of like spread. Maybe you can go into the internals of Node. I'm not going to steal the stage from the expert there, but the I would never probably assign micro CPUs to a Node.js process, just because once again, if you don't have a custom scaler, if you don't write a custom implementation, if you don't know exactly what the runtime is doing, it's just a recipe for disaster, because you're going to spawn tons of instances that they are not even utilized, and they cannot be utilized because they don't have enough to run at full power. Like I said, there is nothing bad in Kubernetes to run this huge pod. Probably my 2 cents after years and years of using Kubernetes is that I would probably kind of like treat it as a glorified ESXi and live with that. But Theo, what do you think about actually micro CPUs in Node? Like a micro Raspberry Pi almost.
Okay, so let me explain this. Makes no sense. Okay. Node.js to run well, okay, and not have performance issues, okay. More or less, you need to allocate at least one virtual CPU, at
Full.
least
Say full.
Full CPU, okay, plus some, okay, because Node.js, even if you just run with one main thread, it has a thread underneath, like for the garbage collector, for the code optimizer, bunch of other stuff like that. So if you want it to be to perform at its best in terms of CPU and response time, you need to give it the CPU power to do the work. Okay. Now a lot of people do this test to verify speed. Okay, the system is not under load, and they verify latency by testing opening a browser. That's how they verify speed. Then the hit production. Many people start doing this at the same time, and everything is slow. Okay, why? Because all those people compete for access on the same CPU. Okay, and to the point of it might be worthwhile to increase the number of threads running the same app. Okay, because even if you can improve the situation. Okay, and you need to be careful in managing, I don't know, health checks and things like that. Anyway.
And any other language already taught us this lesson, right? Because
Yeah, Node.js grows so fast, so big, so quickly that it it didn't have the probably right amount of time to mature around these tools. Okay, and then companies start adopting it, using it, and things went out more or less okayish, but usually with way more resource consumption than expected, which is okay. The companies love to throw money on infra most of the
I
time.
mean,
Well, used to before the crash, but yeah.
but the other thing is that we all come from the microeconomy, right? The microservices revolution, right? With use at the least amount of resources for the least responsibility that you can assign to a service. I mean, in my opinion, that's garbage. But there are many people that they kind of like are fond of that, and in many cases it works. But I never seen it really work at scale effectively. And most of the time, I mean, probably the last thing before we close, and we should still find time to tell the stories. But how many times we have been in that room where we see these 100 microservices making tons of connection between each other, having like these micro CPUs assigned, micro optimization in the memory, and at the end, probably if you install it in a single instance and run all together and call it a day, that was you solve many problems without, because there is an
Yeah,
associated cost of maintenance, cost
the
of
problem.
operation,
Okay,
cost.
sorry. The fundamental problem with microservices. This is, Luca, we are way over time. We need to schedule another session on this because this is like
Then let's
nonsense.
call it the next session. We talk about the microservice.
Microservices. Yes, let's do that. And
So let's
we
do a
talk.
segue, and then we can
So the
close.
fundamental problem of microservices is microservices were born to solve an organizational and team issue. Okay, not a technical one. They move a, a team problem and a people problem into a technical problem.
Yeah.
Now, that can be automated. Okay.
And sorry, Matteo, and we use technology to solve a people and organizational problem. So that's
Yes.
the dog biting his own tail.
Pretty much. Yes. So, and in some cases, this makes absolute sense. But in most cases, it was that this pattern was used, especially when there was not the people problem happening. Okay. Then it was an absolute disaster. And we are going to talk about the disaster in the next
Next episode.
episode.
So with this, I want to thank everyone for joining this conversation. Bear with us. It's a journey. It will become more conversational, more fluid, more engaging. We're working on it. But until then, if you have any question, if you're curious to know anything about Platformatic, if you're curious to know anything about what we discussed, feel free to reach out directly to us, to myself, or to Matteo. And if you really want to see what we are building and you're curious and say, these guys are solving one of my problems, feel free to reach out and we can show you the magic behind our product, our commercial product. And until the next episode, I want to say again, thanks to everyone. Thanks, Matteo, for joining this conversation. And what shall we say, Teo, in Italian? Ciao to everyone.
Ciao. Ciao, ciao.
Ciao.
Ciao, ciao. Okay.
Oh, yeah, keep it open until we upload.